In this video, we're going to talk about the law of cosines. First thing I want you to know about the law of cosines is when you need to use the law of cosines, and you need to use it when you do not know an angle-side pair. So you're going to use the law of cosines when you have side angle side or side side side. Side angle side means you know two sides and an included angle. For example, in my picture here, you can see I have two sides colored in pink and the included angle colored in blue. That would be an example of when I would have side angle side and I would need to use the law of cosines. What I want you to notice about the formula is that the angle that's listed on the end of this formula is going to be formed by these two sides. Angle A is formed by sides B and C. Angle B here is formed by sides A and C. And notice that this angle on the end is opposite this side that's at the beginning of your formula.
The left is going to be opposite this angle here that you end up with, right? Side A, cosine A, side B, cosine B, side C, cosine C. And these two sides here form this angle. B and C, side B and side C form angle A. Side A and side C form angle B, right? And if you look at that, that looks like the Pythagorean theorem. And it basically is. You can see that we got our formula from using the Pythagorean theorem. All right, one thing I want to mention before I start this these next examples is that when you are finding angle measures, you're going to have to round according to the directions in my math lab. And if you were to go back and add up your angle measures, they don't always add up to be 180. Sometimes they just add up to be 179 because you've rounded. So don't let that throw you. If you are one of those type of people that want to check your answers before you actually submit it into my math lab, don't let that rounding throw you off. Sometimes your angle measures only add up to be 179. This is something that that you need to write down here. If you are given side angle side, right? If you need to sketch out the information that you're given to see if this is the type of triangle that you have, then make your sketch. But if you are given this, then your first step is to find the missing side using the law of cosines. Now, there's a lot of times I say it doesn't really matter how you do the problems or which one you find first. There's a reason why we're doing this, and I'll explain all of that in a minute. You're going to find the missing side using your law of cosines. Then your second step is to use the law of sines to find the angle opposite the shorter side, or the shorter of the given two sides. Let's put two given sides. Just rearrange those words. Okay. Use the law of sines to find the angle opposite the shorter of the two given sides. And then my third step is to use sum of angles is 180 degrees to find my third angle. Okay, so use your law of cosines to find the missing side. Then we're going to use the law of sines to find the other side. And then my last step would be to find the other angle. Now, the reason why we are doing these steps in this order goes back to inverse cosine and inverse sine having two different possible answers. And when we looked at law of sines, we looked at those problems in two different ways. We looked at them with that picture of and looking at the height of that triangle and then seeing whether the side was less than the height or equal to the height or greater than the height but less than side A or less than side B or greater than both of the height and side B to figure out how many triangles we had. We're not able to use those pictures with law of cosines, so we have to go back to just our properties with inverses and saying, okay, I could have this angle or I could have 180 minus that angle. We don't want to have to do that if we can avoid it, where we have case one and case two. So if I do the problems in this step, in these order, then I avoid having to have two different cases. I know that my shorter angle is my smaller angle is opposite the shorter side. My biggest angle is opposite the biggest side. So if I had an obtuse angle, I know that it's going to be opposite that biggest side. And so I can go through this process here. Okay, so those are my steps that I'm going to do for this problem. I'm going to be given this angle A is 42 degrees, B is equal to 5, and C is equal to 10. All right, so I have side, angle, side, right? I have this angle that's in between these two sides. These two sides form that angle. So step one is to use the law of cosines to find the missing side. Okay. So I'm given this picture that has angle A in it. So I need to use this formula that has angle A in it. So my formula here, A squared equals B squared plus C squared minus 2BC cosine of A. So A is what I'm trying to find. A squared is equal to 5 squared plus 10 squared minus 2 times 5 times 10 cosine of 42 degrees. Over on the right-hand side, I'm going to do 5 squared and 10 squared. That's 25 and 100. That's 125. 2 times 5 times 10 would be 100. Now, from here, I'm going to take the square root. I'm not going to stick this in my calculator and simplify it and then take the square root. I'm going to take the square root here. So A is going to be the square root of 125 minus 100 cosine of 42. And that's what you would put in your calculator. And that should give you approximately 7.1. You may want to just keep it as 0.12 until you get finished with everything. Okay, so that's step one, finding the missing side. Then use the law of sines to find the angle opposite the shorter of the two given sides. All right, so the shorter of the two given sides is side B. So the next thing I want to do is find angle B. So I have 5 over sine B is 7.12 over sine of 42 degrees. Cross multiply and divide here. So you have sine B equals 5 times the sine of 42 divided by 7.12. So then you're going to do the inverse. So B equals sine inverse of 5 times the sine of 42 divided by 7.12. And that's going to give you approximately 28 degrees on that. And then you would find your third angle by subtracting 180 minus 42 minus 28. And again, you may need to just leave this unrounded until you get to your final answer, but here you got to get approximately 110. The hardest part, I think, of this whole chapter is dealing with this type of problem, just to remember which steps you have to do. This and then the problem where you have two cases with the ambiguous case where you have two possible triangles. I think those are the hardest two types of problems. Okay. So my next set of problem, or next set of problem, just next problem, just got with one. This is when you're given side, side, side. So there's a certain process that we're going to work through here as well. Your first step here is to find the angle opposite the longest side using the law of cosines. So again, you know, when we're taking inverse sine, inverse cosine, there's two possible answers that are less than 180. And I don't know that I've stressed this, but the reason why we're only looking at those angle measures from the first and second quadrant less than 180 is because I cannot have an angle more than 180 in a triangle. So I know that the angle is either the acute angle that's given or 180 minus that. And I know that if I'm given a triangle with all three sides given to me, the lengths of all three sides, I know that if I have an obtuse angle, there's only going to be one of them, and it would be opposite the longest side. So if I figured that out first, then I know how I no longer have to worry about case one, case two, and getting two possible triangles out of this. Okay. So that would be my first step. Find the angle opposite the longest side using the law of cosines. And then I'm going to find one of the other two angles using the law of sines. And then my third step, I want to try and write it out like I did this step over here. Use sum of angles is 180 degrees to find the third angle. So don't get these two types of problems confused. Here I'm starting off by finding the angle opposite the longest side. Step 2 here, you're going to find the angle opposite the shorter side. So I think that's the thing that's the hardest to remember out of all of this stuff that we're doing. Okay, so let me do an example of this type of problem. Now, you probably will not be given a picture. You will probably just be given the side lengths. So I would just go ahead and sketch out a picture anyway. Doesn't have to be real accurate. Your first step is to find the angle opposite the longest side. So I want to find angle B. Right? Side B is the longest, so I want to find angle B. So I've got this formula here that I'm using. So I have 7 squared equals 4 squared plus 5 squared minus 2 times 4 times 5 times cosine of B. So this is 49 equals 41 minus 40 cosine B. Subtract 41. So 8. Divide by 40. Of negative 1/5. So B is the inverse cosine of negative 1/5. And that is going to give you approximately 101.537. I believe in my math lab, they're going to ask you to round to the nearest degree. So you would type in 102 for your answer, but we're going to stick with the 101.537 when we're working through the rest of this problem. And once you put the numbers into your formula, the rest of this is just basic algebra. Until you get down to the very last step, then you're having to use inverse cosines again. All right, so now I know what side or angle B is. So I need to find one of the other two angles using the law of sines. It doesn't matter which one. I think what I did was just did them in alphabetical order. I found A. Sine A is 7 over sine 1.01537, 101.537. So there's my proportion using the law of sines. And that's going to allow me to find angle A. So I cross multiply, divide. So sine A is 4 times the sine of 101.537 degrees divided by 7. So you're going to use inverse sine. So you're going to put this into your calculator. And you're going to get A to be approximately 34 degrees. All right, so I'm given all three sides, and I've just found two of the angles. So my third angle is C, so I do 180 minus those two. And again, you may want to put in 101.537 here instead of 102. But anyway, I'm going to give about 44 degrees for my final answer on that.